Hi, Math 92, Chapter 13. Here, first, we talk about some formula in the logarithm. So I left a copy of the notes from the textbook and to show you some of the formulas, some of the basic one that you already have it in pre-algebra. And then we start with the very first problems. The very first problems that we have, it's a copy of that. These are the keys. And that is how to evaluate the log without using the calculator, this 1 and 2. Okay, so what is the log? On your calculator, you have this log and also ln. If I want to calculate log of 7, so basically it's depending on what type of calculator you're using. On your calculator, you look for log, which in my case is here. And to calculate log of 7, I just say log and 7. And the calculator would give you the number, which here is 0.845. Or if you want to calculate, let's say, log of, I don't know, like 157, log 157, again on your calculator, you have log 157. And when you enter it, it gives you this number, 2.1958. Depend on how many digits you want to run after the decimal. But here, 2.19, let's say 2.196. They also have it for, they call it natural log, which is this ln. Natural log, which is this ln. So if I want to calculate natural log of 7, natural log of 7, you have this ln here. You just press ln and then 7. And you come up with different numbers. You see that? 1945, 1.945. So you understand that there is a difference between log and ln. This is a natural logarithm, and this is ln. So these two are different. Now, calculator, every log has a base. This they call it a base. The calculator is designed for base of 10. So when we ask you to calculate log of 7 and you don't see any number for the base, means base is 10. You don't have to show the 10. So the calculator is designed based on 10. Like if I ask you to calculate log of 157, what's the base? 10. So all you need to do is just go and put log and then 157. Now, if the base is difference, is not 10, for instance, we want to calculate log of 7 with base of 3. In that case, we have a formula which if you have log of a with base of b, you could write it as ratio of log of a over log of b, and both are base of 10. So if I want to calculate log of 7 base 3, log of 7 base 3 is log of 7 divided by log of 3, and both have the base of 10. So how do I calculate? Then on my calculator, I put log of 7 divide by log of 3, log of 3. Enter at 1.77. Okay? So if the base is different, you could use this formula and calculate the base. Like, see how we calculate log of 157 base 10? Let's say I want to calculate log of 157, let's say with base of like 5, okay? In that case, you cannot just type log of 157 in this calculator. The calculator is designed for base of 10. So you have to use this formula and write it as log of 157 over log of 5. Then you use your calculator, you said log of 157 divided by log of 5, and that gives you 3.1416 or 3.14. Okay. So this is one of the formula that we need to remember if the base is not 10. Now, what is E? E is the number that I can use on my calculator. You know, in the calculator, you see here I have e to power of x. Here, the blue in this calculator, but as I said, just depends what type of calculator you're using. But E, they call it Neperian number. It's like, you remember pi in trigonometry, pi was 3.147. It was very large numbers right after the decimal. E is very similar to pi, which is this number. E is 2.71828. This is what the E is, right? Now, let's say you want to calculate log of 7 with this base, 2.71828, or just say log of 7 with base of E. In algebra, when the base is E, instead of calculating log of 7 over log of 2.71828, instead of doing that using this formula, log of 7 base E, we convert it to natural log of 7. What does natural log of 7 means? Means log of that number with base of E. So in that case, if I want to calculate log of 7 base of E, all I need to do is use the calculator and calculate natural log of 7, which is this number. Natural log of 7, which is 1.9459. Okay, so natural log means log with base of E. That's what natural log is. And all the formula that we use for log, they all apply for ln. So here in this one, they're asking you to do the calculations without a calculator, okay? They don't want you to use the calculator for this. However, when you have it online, you could actually do it. But so there are two ways to do it. One is log of 81 based on 9. You just write it as log of 81 over 9. Or what if I have log of 7 with base of 7? Log of 7 with base of 7 is log of 7 over log of 7, which cancel is 1. But what if there is a power, like we want to do log of 49 base of 7? 49, we write it as log of 49 over log of 7. So far I'm using, again, this formula, that log of A with base of A. B is log of A over log of B, okay? We also have a formula that if you have, let's say, log of A to power of N with base of B, this power can go in front of the log and write it as N log of A with base of B. So the power can always go to the front, and it's also, you could do it reverse too. So log of 49, we understand log of 49. 49 is 7 to power of 2 over log of 7, right? Then this 2 goes to the front of the log. Cancel, the outcome is 2. So here, log of 81, we write it as log of 81 with base of 9, which is log of 81 over log of 9, or log of 9 to power of 2 over log of 9, and then 2 goes to the front. So the outcome is 2. Number 2, log of 10,000. 10,000 is what? It's log of 10 to power of 4, right? Then the 4 goes to the front of the log, is 4 log of 10. Log of 10, if I use my calculator for log of 10 is 1. So the outcome is 4. Why log of 10 is 1? Because the base, if you don't see any number here, the base is always 10. So log of 10 with base of 10 is just 1. So far, these are the formula that we have used. One is log of A with any base is log of A over log of B. If you have log of A to power of N, or E, the letter can be any difference. When you're looking at the textbook, they might have used different letters, but the principle is the same. This N can go to the front, and you write it like that. So this is 2 formula. There is also a formula that if you have log of A with base of B is equal to the number, let's say the number is like N, then if you want to get rid of LOG, then A means what you have after LOG is the base to power of numbers on the other side. You take the base and write it the number and the power there, right? So let's say this problem's 81 base 9. You could also do it this way, that if you have I have log of 81 base 9 is equal to what, right? or is equal to n. So according to this formula, if you have log of 81 with base of 9 is equal to n, 81 is 9 to power of n. But we understand 81 is 9 to power of 2. So what is the value of n? Equal to 2. This is another way to do it using that formula. So far we have introduced the formula. Now, this problem's number 3, log of 1/64 with the base of 2. What formula do I use in order to switch 1/64 to 2 power of -6? In algebra, we have a formula that x to power of negative number is 1 over x to power of positive number. All right? So if you have 1 over 64 or 1 over 2 to power of 6, then you have what? You have 2 to power of -6. This is what we use for problem number 3. See, because x is 2, n is 6, so you could always change it. So that means if you want to change a fraction to the negative power, that's how you do it. That's another formula that we are using here. The same thing here. 1/16 is what? It's here. 1/16. Or 1 over 2 to power of 4 would be 2 to power of -4. That's what we use here. Now here, number 6, what formula do I use to bring the power to the front? And log of 2 based on 2 is 1, right? Because log of 2 over log of 2 is 1. On number 8, 9, and 10, they just ask you to use the calculator, okay? So you just type log 8,000 using the calculator, ln. This one, if the base is different, see, base is 8. So we are using this formula first, and we change it, log of 0.39 over 8, we change it to log of 0.39 over log of 8, then you use your calculator to come with that number. The same thing here. Log of this number base is 19, is different, right? You just write it like this and calculate. And they ask you to run the answer to the 3 decimals. So you gotta go just 3 decimals after. So remember for this 2, 10, and 11, we are using this formula if the base is not 10. In page 4, this MNA is explanation of this formula. We are just using the different letters, okay? It's the same. A, B, N, or here MNA. It's just you understand that if you have the LOG and you want to get rid of the log, you take the base and raise it to the power. Like what? What is log of 3 with base of 2? What is it? Instead of question, put the X here. According to this formula, if you want to get rid of LOG, what you have after LOG, which is 3, you write that, and then you take the base and raise it to that power. Same thing here. Log of 81 over 3, you could do it this way. We are using, now we show you how to use this formula here. See? That means you go from this to that, from this to that, from this one to load. It's vice versa. You go from the number to log using this formula. Same thing here. All these problems, number 16. You know? We are using this formula. We go from this to that. You go from this to LOG, not LOG to LOG, and then you do the calculate, everything again. Same thing. We are using this formula. 18, 19, they all are very similar. You go from that to log. You go from this to the log. You need to identify what is your base, what is the number after the log, and what is on the other side. See? This is a word problems, number 21, but here we are using this formula. Number 22, 23, it's a longer problem, long calculation, but you see how I use the formula here? Then we go to compound interest. There are two formulas for the compound. This is continuous, this is compound. There are some examples here. You want to look at the example, then here. This problem number 3 is a compounding continuously. I use that formula. This page 11 is compounded interest. Okay. And the last one, again, we are using the formula for page 13 and page 14. So that would be end of this one.